In this video, we're going to look at the domain of a function when our function is given as an equation. So it's pretty straightforward if you have a pictorial representation of a function or a set of ordered pairs. It's pretty straightforward to write down the domain and range. What if your function is an equation, a formula? Well, in this case, you can think of the domain as the set of real numbers that x is allowed to be. So let's look at some examples here. What if this is your equation for your function? What do we have here? We have a fraction. And whenever you have a fraction or rational expression, the denominator is not allowed to be 0. So what is the denominator in this case? It's 2x plus 5. So that's not allowed to be 0. But you're not done, because you have to express the domain as what the restriction is on x. This is telling you that 2x plus 5 is not allowed to be 0. So you have to change this to where x is by itself. So the next thing I would do is to subtract 5 from both sides. And so that tells you that 2x is not equal to negative 5. And now to get x by itself, you're going to want to divide both sides by 2. And so this leads you to the restriction that x is not allowed to be negative 5/2. Now, what is the domain? The domain is the set of real numbers that x is allowed to be. So the domain, in words, is x can be any real number except negative 5/2. Now, that is a correct answer. There is nothing wrong about whether or not that's a true statement. That statement is true. But now, what if you're required to write your answer in interval formation, interval notation, or in set builder notation? So what would it be like in set builder notation? Well, x can be any real number as long as x is not equal to negative 5/2. Or sometimes it'll just be written like that. Either one of those is fine. Okay. You could give it as a number line. What would it look like on the number line? Well, you would find where negative 5/2 is, and you have to omit it. It's not allowed to be negative 5/2, but it can be anything else. So what I'm drawing here would be a correct answer. And then finally, in interval notation, what would your answer look like? Well, you have the number line. Read it off from left to right. So we come in from negative infinity all the way to, but we do not include negative 5/2. We have a gap there and have to jump over it. And then we want everything to the right. And so more often than not, on final exams, you'll see the answer presented as an interval. And let's check this over here in your lab notes. These are the steps that have been written out for that. Okay. All right, so let's look at these example 7 and example 8, and then we'll be done. So we're done with this one here. Now, suppose this is our formula. This is our function. What is the domain going to be? Well, we have a square root. And if you have an even root, which a square root is, so square root, fourth root, square root, fourth root, sixth root, eighth root, etc. The argument, which is what's inside, so the argument, the stuff that's inside of an even root, cannot be a negative number, cannot be negative. So for this example, this means that what's inside here, 2x plus 5, it cannot be negative. That means it has to be greater than or equal to 0. All right, the opposite of negative is not positive, because 0 is a number that's neither negative nor positive. So if what's inside, if the argument cannot be negative, then the argument has to be greater than or equal to 0. Now, once again, you have to give the restriction just for x, and we don't have x by itself on the left-hand side. So what do? Well, I can subtract 5 from both sides, and then that's going to give me the restriction on 2x now. And now to get x by itself, I can divide both sides by 2, and then that's going to lead me to the restriction. Well, the 2's will cancel, and that's going to lead me to the restriction that x is greater than or equal to -5/2. So this is what x is allowed to be. So in set builder notation, x is any real number as long as it's greater than or equal to -5/2. On the number line, I'm sorry, let me do that in black first. On the number line, you find -5/2. And what does this say? X is greater than or equal. So we're going to start at, we're going to include, and then greater than is going to be everything to the right. So this is what it would look like on a number line. And then what would the answer be if we were asked to give it in interval notation? Well, looking at the number line, reading it off from left to right, we start at and we include -5/2, and then we go off with no gaps forever. Okay. And so now if we go back to the lab notes for lab 5, example 7, here's the step-by-step calculations, and here's our answer. Okay. And so now let's get to example 8. What's the domain of that? Okay. Well, we have 2 restrictions that apply here. We do have a fraction, so the denominator is not allowed to be 0. We do have an even root, so the argument of the root has to be greater than or equal to 0. But both of these restrictions have to apply. So the way that both of these apply is together our argument, well, our argument cannot be equal to 0 because the square root of 0 is 0, and that would give us 0 on the bottom. So here is the restriction when you have an even root as your denominator. Okay, so this means that our argument here, 2x plus 5, is strictly greater than 0. And now I have to give the restriction just so x is by itself. So that'll tell me 2x is strictly greater than -5. Then dividing both sides by 2, that tells me that x itself is strictly greater than -5/2. So in set builder notation, it would look like that. As the number line, you would start at -5/2, but not include it, and then have everything to the right. And then in interval notation, you would start at but not include -5/2, and then go on forever. So there is a slight difference between example 7 and example 8. And make sure you understand the difference between those two, because on the final exam, you're going to get multiple choice answers, selections. And as you can see, if you look at example 7, look at the correct answer for example 7, and then look at example 8, look at the correct answer for that. The only thing that's different there is that symbol. You use square brackets for inclusion, and you use parentheses for not included. So that was from the lab that we did on interval notation. So make sure you understand the difference here. If it's in the denominator, you have to exclude it being equal to 0. What makes the denominator 0? If it's just an even root on its own, then the argument is greater than or equal to 0. It's allowed to be 0 on the inside there, but not if it's the denominator of a fraction. So that ends this part of the video, and that covers all of Lab 5.